Tonight we're going to complete the notes for pages 7 and 8, and the title for these pages will be Quadratic Functions. So make sure you fill out your table of contents and then turn to page 8. I want you to give this page the title Quadratic Functions, and then we're going to start with the yellow sheet that is titled Second Differences and Quadratic Functions. So go ahead and tape that in on page 8. First of all, we have this delta column that we've already talked about is the difference column, and we find the difference, remember, from figuring out how much we would have to go from -2 to 0, so that would be, we'd go up by 2, and then from 0 to 16 we'd be going up by 16, and then 16 to 46 would be going up by 30, and 46 to 90 would be a difference of 44. So notice this function cannot be linear because we do not have a constant difference. So we already know it's not linear. At that point, we're going to go ahead and move over to what we call the second difference, and that's drawn with this little triangle that has the squared symbol over it, but it's not actually the difference times the difference. We call that the second difference. So this column is going to be the second difference, and really that just means that we're going to find the difference of the difference that we've already found. So 2 to 16 gives us a difference of 14, and 16 to 30 is also a difference of 14, and 30 to 44 is another difference of 14. So notice that now we have our second difference that's constant. We found 14 was the second difference every single time. Okay. So when the second difference is constant, the function is quadratic. So we know that this function has to be a quadratic function because it had a constant second difference. So let's talk about exactly what that means and how we could define a function using this table. We'll start just like we did for linear functions. We'll start with our recursive functions. So remember that when we're defining a recursive function, we want to start with our first output. And we will decide and state what is our first input. And then the second line of our quadratic function is actually going to always follow the same rule. So we will always have f of x minus 1 plus our second difference times x minus 1 plus our first difference. And that's going to be for all other inputs. Okay, so we're going to talk about exactly what that means, and we'll do an example using this table that we have up here. We always start with our f of x function notation and our squiggly brackets. So go ahead and fill in your f of x and your squiggly brackets. And then let's talk about where these numbers are coming from. We have our first output, which I'm going to highlight green, and then I'm going to come up into our table and highlight my first output in green also. That way, when I come to look at these notes later and I see that my example says first output and it's highlighted green in these two places, that can be a trigger to say, oh yeah, that's where I'm going to find that first output, is that place next to 0 in my table. So we found that it was -2, and that was for our first input, and in this case our first input was 0. So we're going to go ahead, I'm going to do the same thing and highlight again. That way I remember to come back and look at my table. Oh yeah, my first input was 0, that's where I got that from. So that's if x equals 0. Okay, So f of x minus 1, I don't need to highlight that because it's never going to change. It's always going to be f of x minus 1 plus, and then I do want to highlight my delta squared because that is going to change. It's dependent on your table. So the delta squared we got from our second difference column. So in this case, it's going to be 14. I'm not going to highlight the x minus 1 because that's always going to stay x minus 1. And we're just going to plug it in. And then we have to add our delta. And in this case, our delta is, if I look at my table, the very first delta that we had was 2. So I'm going to go ahead and plug in 2. And then all other inputs just means that in this table, our inputs, we've already counted for 0, and now we need to account for 1, 2, 3, 4, which are numbers that are greater than 0. So this is if x is greater than 0. We have one last step, because this is not simplified. We can actually go through and multiply through by this 14 and distribute that. So we're going to go ahead and do that. Multiplied 14 times x, and then 14 times negative 1 is negative 14, plus 2. So if I simplify all of that, I end up with 14x minus 12. Okay. So I'm going to rewrite this function so it's a little bit cleaner, and I'm just going to use that 14x minus 2. So our final function, simplified, is negative 2 if x equals 0. Sometimes we write that if and sometimes we don't. As long as you have this comma in there, it doesn't matter which way you do it. Okay. Then I'm going to write my simplified function, f of x minus 1 plus 14x minus 12. And that's if x is greater than 0. So now we have simplified our function, and this is our recursive function for our quadratic table. All right, I want you to go on to page 7. And on page 7, we are going to complete the explicit quadratic function notes. So go ahead and tape those in on page 7. Notice we're looking at the exact same table. So when we are writing an explicit quadratic function, it will always be in the form f of x equals some number times x squared plus some number times x plus some constant number at the end. We need to find that a, b, and c. So that's our goal, is to find a, b, and c. We're going to use the table to help us. So the first thing we need to find is that a, and a equals half times our second difference. So I'm going to draw a squiggly line down the middle so that I can have my instructions on the left and my example on the right. So I'm going to highlight my second difference here, and I'm going to highlight it in the table so that I remember where to look to find it. So for this example, a equals 1/2 times my second difference is 14. So a equals 7. All right, and I'm going to go ahead and highlight now my a's. So I'm going to remember that to find a in my function, this is where I'm going to look for those steps and how to do that. All right, so our next column that we need is we need to find this a times x squared from our function. Okay, that's going to help us figure out the rest of our function. So we're going to make a new column, and our new column is going to be a times x squared. One thing that I find helpful to do is to go ahead over here on the left, make myself a new column that's x squared, so I don't have to keep calculating that. So 0 squared is 0, 1 squared is 1. All right, that will help me when I'm multiplying to find a times x squared. So we already found that a was 7, so all I have to do to fill out this column is multiply. 7 times 0 gives me 0. 7 times 1 is 7. So now that we've figured out what ax squared is equal to, we can think about the fact that in our function, if we subtract this away from our output, then whatever will be left will be bx plus c. So I'm going to take our output and subtract out the amount that is accounted for by our ax squared. So we're going to say output minus ax squared. So we're subtracting -2 minus 0 gave us -2. And 0 minus 7 gave us -7. 16 minus 28 is -12. 46 minus 63 is -17. And at this point, I often start noticing that there's a pattern. So at this point, I've noticed that there's a pattern that we are subtracting 5 each time. So I often won't actually subtract those. I will just use the pattern and say, all right, if I subtracted 5 again, I'd have -22. I like to use patterns to help me simplify my work. All right, so we have calculated this new output minus ax squared. So this that is left is really our linear function that we have left after we have subtracted out the ax squared term. We already know how to write a function for a linear function, and we know that we need a delta to do that. We need to find our constant difference. So I'm going to use this delta, and I'm going to underline it to remind myself that I'm actually using this modified part of my table for that delta. And we've already talked about the fact that we found that that delta was -5. And if you don't want to have to write all those, you can just draw an arrow, or you can write them all out. It's up to you whether you want to take the time to write them all out. All right, so now we can finish writing our function. So when we are writing this part of our linear function, we already know that the b term in front of the x comes from our constant difference. So we're going to go over here and write that b equals that new delta column, and I'm going to highlight that to remember where that is in my table. So that was our new difference. Okay, and I'm also going to highlight the b since I didn't actually have to do any calculating. I'm going to highlight that b and highlight it up in my function as well. That way I can remember that if I need to find that b, I can look for the blue highlights and know exactly what I need to do. So over here, we're going to, for our example, we found that b is -5. And I'm going to go ahead and highlight that also just to remember as I'm doing my example. Keep all my colors the same. All right, the last thing we have to find is our c. And since we are looking at this last two columns for our linear part of our function, we're going to look the same as we would before for our output that's next to 0. In this case, it is -2. So we're going to look at output minus ax squared, that was this column here, or input 0. Okay, and so I am going to actually highlight that, and we're going to highlight the -2 because in our example it's going to be -2, and we're going to highlight our c up in our function. So in our example, we found that c was equal to -2. Okay, our last step. So when we are done, we have to have a function that looks exactly like this. The only difference is we'll actually fill in numbers for a, b, and c. So now we're ready to write our function. I'll move that up so you guys can see it. Okay, so we have f of x. We're always going to start with our f of x. We found that a was 7, so we're going to plug in 7. We don't change the x squared, it's always going to stay x squared. And we are going to fill in -5 for our b. We still want the x, and our last term is going to be -2. And now you have completed your quadratic function for this table. This is our explicit function.